Welcome back to this channel again. Today we are asked to calculate and prove that the yellow area here is 13.79 using integrals. So if you notice here, we have a semicircle with the top represented here. If you look at the radius, if we count, the radius is 8, and we know that the general equation of a circle is x squared plus y squared is equal to r squared if it is centered at the origin 0, 0. With r here is equal to 8, we can get that x squared plus y squared is equal to 64, and we can pull y because this is what we are going to find out, integral of y over a variation of dx of x small element. So if we have y is equal to square root of 64 minus x squared, we'll be interested in that. And if we look at the graph, it is between lines 3 and lines 5, so the intersection of our circle with these two lines and the area delimited with between these two lines and the curve is really what we are going to calculate, like the area under the curve between these two lines. So integral between 3 and 5 of square root of 64 minus x squared dx is the one we are going to try to calculate here. Okay, so we are going to go ahead and try to do the calculation. And if we rewrite here integral of 64 minus x squared dx between 3 and 5, we are going to forget this definite integral and go to the indefinite integral without the 3 and the 5 and try to calculate the values here. And if we have that one, integral indefinite one of square root of 64 minus x squared dx, we can take the form of x is equal to 8 sine theta, with theta being an angle. So x squared becomes 64 sine squared theta, and if you take the derivative of both sides, we get dx is equal to 8 cosine x dx dt. I mean 8 cosine theta d theta. So that becomes here, our equation becomes integral of square root of 64 minus 64 cosine squared theta and times 8 cosine theta d theta. Just plugging in, okay? So if we go further, we can pull out the 64, it becomes 8. So we get integral of 8 times square root of 1 minus sine squared theta times 8 cosine theta d theta. That gets us, we pull out the 64 of integral of, now we know that 1 minus sine squared theta is cosine squared theta. We pull it out, so it becomes cosine theta times cosine theta, that's cosine squared theta and d theta. So the d theta here, we can use our trigonometric formulas. We know that cosine 2 theta is cosine squared theta minus sine squared theta is also equal to 2 cosine squared theta minus 1. That yields that cosine squared theta, if we pull it out, is equal to cosine 2 theta plus 1 over 2. So we are going to plug this one in and we get a simple integral now, and everything will be solved. So 64 integral of cosine squared theta d theta is equal to the 64 and the 2 just yield 32, 64 divided by 2, and integral of cosine 2 theta plus 1 d theta, correct? And we are going to split this one, and because it's an addition, we can say that is equal to 32 integral of cosine 2 theta d theta plus integral of d theta, 32 integral of d theta. Now we can just calculate this, something we know. You know what if we take the derivative of half of sine 2 theta, we get cosine 2 theta. So we will get here 32 times 1/2 of sine 2 theta, not theta, plus 32 theta plus a constant. That will be our result. So make sure that we write, I will correct this typo. This is sine 2 theta, not sine theta. Okay, but we know that sine theta is equal to x over 8, and theta is sine minus 1 of x over 8. So if we rewrite our result here, we are going to plug in our values, and we know that sine 2 theta is 2 sine theta cosine theta. Okay, so we are going to replace that. So sine theta being equal to x over 8, and theta is equal to arc sine of x over 8, cosine theta becomes square root of 1 minus sine squared theta is equal to the square root of 1 minus x squared over 64. If we pull out the 64, we get cosine theta is equal to 1/8 of square root of 64 minus x squared. Okay, so if we go there, now we are going to plug in these values. So our integral becomes integral of 64 minus x squared dx is equal to 32 times 1/2 times 2 times sine theta cosine theta plus 32 theta plus a constant. Now we have to do some simplifications here, and we have to make plug-ins. We have to get x's here now. So 32 times x over 8, okay, that's sine theta, and cosine theta is 1/8 of square root of 64 minus x squared, and then plus 32, and we know that it is arc sine or sine minus 1 of x over 8 plus a constant. Now we are going to do some simplifications here. We're going to simplify, and we get integral of square root of 64 minus x squared dx is equal to 1/2 of x square root of 64 minus x squared plus 32 sine minus 1 of x over 8, okay, plus a constant. Now we are going to limit that to between 3 and 5 and do the calculations. This is the end of the problem, so we can go back and have a look at what the original equation was. We know that we wanted between 3 and 5, okay. These are the two lines, the boundaries. So we can say that integral from 3 to 5, okay, of square root of 64 minus x squared dx is equal to half of x 64 minus x squared plus 32 sine minus 1 of x over 8 between 3 and 5. Okay, so we are going to evaluate that. I'm going to plug in the 5 and plug in the 3. So all these expression, plug in the 5 minus all the expression, plug in the 3. So 1/2 of 5 square root 64 minus 5 squared plus 32 sine minus 1. Now this arc sine has to be in radian. So if you are doing this with a calculator, make sure that the mode is radian, not degrees, because if you don't do that, this will be wrong. So minus, now we plug in the 3 square root 64 minus 3 squared plus 32 sine minus 1 3 over 8. So we close the parentheses. So now if we calculate these two amounts here, we get 37.2167 minus 23.425. Okay, the first expression we can use calculator and calculate this. Make sure that your arc is in radian and not degrees. Okay, so that should yield now 13.7917, and this is what they asked us to prove. So thank you for watching, and I will see you in another wonderful video.